Alright, what is up, everybody? We are here in Unit 10. So Unit 10 is a refresh on area, and we kind of go over some area of some new shapes that we've covered already this year, but we never actually did the area. And kind of where the next two units are all going is area leads to surface area, so the area around a three-dimensional object, and then surface area then leads to volume, the total amount of space inside a three-dimensional figure. All right, and then after that, we have probability, and then the semester is done. So we're looking at 3 more units, 10, 11, and 12. 10, 11, 12, yeah. And that's all she wrote. There might be a little bit extra for Algebra 2 at the very end, if I remember correctly. So today we're getting into parallelograms and triangles. So let's do a quick review of a parallelogram. It's been a while since we've talked about one. So remember, the key term here is parallel, right? So a parallelogram, we know, has 2 pairs of opposite sides that are parallel. So the top and the bottom have those double arrows. The left and the right have the double arrows. So knowing that the opposite sides are parallel. Okay, now the tendency for people in a shape like this is to think it's just like a rectangle, right? And if we know area of a rectangle, that's just the base times the height, just like a square. And so if you took that idea and you applied it to this figure here on our left, you'd think, okay, well, here's our base and here's our height, so it must be that bottom length times that side length. And that is where people are going to get this incorrect. Okay, so it is a base times height formula, but height is perpendicular to the base. Remember, and if something's perpendicular, it's forming a right angle. So notice that this side is not perpendicular to this base, right? So this angle right here is not a right angle. So instead, our height is that perpendicular green length from base to base. So the important thing to remember is that with a parallelogram, base times height is going to be our area, but the height is the perpendicular distance from base to base. So it is not the length of this highlighted length. Number one mistake people make is they'll do base times that yellow, and that's incorrect. So parallelogram, super easy to find the area, just base times height, but you got to remember the height is the distance from the bases, and it's a perpendicular distance. Okay. Good old triangle. Okay. We've talked about triangle area before, 1/2 base times height. But remember, there's going to be 3 different variations of a triangle that you're looking at. There's the acute, the right, and the obtuse. And the height of the triangle really determines on kind of how it's laid out, how it's given. But here's the 3 most common scenarios. If you have an acute triangle, like the one on the left, okay, and guys, we're going to use the base as all this, the orientation, right? So if the bottom of the triangle, as we're looking at it, we're going to make that the base. So for the acute triangle on the left, the height still applies. It's still a perpendicular distance from the base, but it goes to the opposite vertex. So for an acute triangle, most of the time the height is going to be inside the triangle, like this. Okay? For a right triangle, our height is usually going to be one of our legs. So in this case, this guy right here. And for an obtuse triangle, our height is outside our triangle. Because notice this is the side, this is the vertex that's opposite our base. And so when we make that perpendicular distance, when we do it inside, it's not reaching an opposite vertex. Sorry guys, my dog was barking. So within the obtuse triangle, and the base is one of the shorter 2 sides, the height's going to be outside. Now, if it was an obtuse triangle like this, notice how my base is now the long side. Then, in that instance, my height would be inside my triangle. So it kind of just all depends on the layout of the triangle. I'm just showing you guys the different variations of what you might see. Okay, and usually it's going to be one of those 3 types, where it's going to be the height's inside the triangle, the height's one of the sides of the triangle, or the heights outside the triangle. And as I said earlier, our formula for area is just 1/2 base times height, okay? Or just base times height divided by 2, however you want to look at it. So let's do a couple of different example problems. So this one says, find the perimeter and area of each figure. So in this case, if it looks like a parallelogram, let's just assume it is a parallelogram. So that would mean that this right here is 17. And so we know opposite sides are parallel and congruent. So our perimeter would be 17 plus 17 plus, I know the top and bottom are both the same length, 21 plus 21. So my perimeter is going to be 17 plus 17 plus 21 plus 21, 76 centimeters. Pretty straightforward. Now for our area, we need to find the red dotted height. And what's happening in this diagram is this right here is telling us that this length in yellow is 8 centimeters. So for this problem, to find our h, we have to do Pythagorean theorem. Because notice that we have a right triangle right here. The h and the 8 are our legs, so h squared plus 8 squared equals 17 squared. H squared plus 64 equals 17 squared is 289. Subtract 64 from 289, we get h squared equals 225. Square root of 225 is 15. So our height is 15. So now to find our area, we just do 21 times 15. And that gets us 315 centimeters squared. So that's just a problem that you might see where they're giving you side lengths, but you have to find the height using Pythagorean theorem. All right? A little bit of overlap here. Sorry about that. Okay? Now with this problem, the side length that we are missing is this, right? Now we can actually find our area. Our base is 23. Our height, that distance here, would be the same distance here. So our area is 23 times 24, which is 552. And that's to actually find our perimeter, we need to use Pythagorean theorem to find that length in red. So in this case, the 7 and 24 are our legs. So 7 squared plus 24 squared equals, we'll call that x squared. So 49 plus 24 times 24 is 576. So 576 plus 49 is 625. So x squared equals 625. Square root of 625 is 25. So our perimeter is 23 plus 23 plus 25 plus 25, or 50 plus 46, 96. Easy. Let's get the triangles. Okay, let's not worry about perimeter. We'll just talk about it a little bit. But so looking at this triangle here, right? So you might think, okay, well, which one do I use as my base? My advice is always use the side length that you're given a height for. So what I mean by that is, notice that this 30 is perpendicular to the 19. And it's connected to the vertex opposite of the 19. So in this case, my base would be 19 and my height would be 30. So my area formula would be 1/2 base times height. Okay, so again, if I wanted to use 41 as my height, I'd need to know what this purple length is right here. If I wanted to use the other side length as my height, I'd have to extend this side and I'd need this distance right over here. Because remember, the height has to be perpendicular to the side length that you're calling the base. So 1/2 times 30 is 15, so 15 times 19 is 285. So my area is 285 inches squared. And then if I wanted to find my perimeter, I would need to find this length, and I would use my right triangle here. Let's call this y, be 27 squared plus 30 squared equals y squared. And you guys can totally do that problem on your own. Okay. Another one. Okay, so in this instance, right, this is a right triangle, because if this is a right angle, then this over here is a right angle as well. So we need this green length to be able to find the area of this triangle. Pythagorean theorem once again. So again, let's call this h. H squared plus 6 squared equals 13 squared. Okay, and once you find what h is, it would be area equals 1/2 29 times whatever h is. Okay. Now there's a couple problems I want to show you that use some information from previous sections, and then we'll be all done. So go ahead and look at these two diagrams. So notice you're not given very much information pertaining them. So for the one on the left, I know that this distance in green is 17, which also means that this distance in the bottom is also 17. So I need the red dotted length in order to find the area of this parallelogram. Now here's the key to doing these problems. Focus your attention on this triangle. Well, I know that this is a right angle right here. This is 45. So what's the measure of this angle here? It's also 45. So that is a 45, 45, 90. And remember, with our 45, 45, 90, the legs are the same length. So that means that since this right here is 9, then this right here would also be 9. So my area is just 17 times 9. 17 times 9 is 153. So my area is 153 yards squared. Same concept, okay, with our figure on the right. We have 32, which means this bottom part here is 32. We have a 30-degree angle at the top, which means this is 60. So this is a 30, 60, 90. Whoop, terrible drawing. Holy moly. Sorry about that. So if this is my 60 and this is my 30, remember it's x, 2x, x rad 3. So if this length here in yellow is 12, and that's my 60 leg, this length, the red dotted line, would be whatever my 60 leg is times radical 3. So 12 rad 3. Now usually with area, we're going to put it as a decimal. So if I do 12 times the square root of 3, it gets me